Welcome back from an ad break, and now let's continue. So now we're going to be looking at the relationship between the processes and this change of state, whereby we're going to be looking at the flow diagrams and the graphs that are going to be explaining how the change of state happens. So what's important to note is that the change of state always involves, number one, the absorption of energy and the release of energy. That for a change of state to happen, we either need to be adding energy or we need to be removing energy. And those two processes are going to be referred to as the absorption of energy when we're adding the energy into the substance. And when we are removing the energy, we are going to be now releasing the energy. Now, the second part that the change of state always involves is the arrangement of the particles. Remember that whenever we are changing the state, we are moving from a solid to a liquid into a gas. And in all those states, the particles that are making up that particular matter, they are arranged differently. So in a solid, we know that the particles are tightly packed, and then in a liquid, they are loosely packed, and then in a gas, they are at random. They are just floating around in a particular container. So in all those phases, the arrangement of the particles is different. So to recap, the change of state always involves energy and also the arrangement of the particles. So the change of state as the physical change, what are we talking about there? Now we're looking at the molecules, or referred to as the particles of a substance, which do not change their composition. Because once they change their composition, that is going to be referred to as a chemical change. By that I mean, if we were to look at water with a chemical formula of H2O, the ice block, the ice that is formed from the water, it still has the composition of 2 hydrogens and 1 oxygen. Even if it's in a liquid state, it's still going to be H2O. Even as the water vapor, we have particles of the water vapor that are still H2O, that are still composed of 2 hydrogens and 1 oxygen. The moment we start breaking that molecule into hydrogen and oxygen, we are now talking about the chemical change. We're no longer focusing on the physical change. So in a physical change, what's important to note is that the composition of the particles will remain the same. So even in a gaseous state, when a liquid has turned into a gas, that gas still has molecules of water that have the molecular formula of H2O. So the moment we start breaking that H2O into two molecules of hydrogen and oxygen, this now is going to be a chemical change, because we have changed the composition of the molecule into a hydrogen and an oxygen. So in simple terms, what we are saying is that the particles before and after the change of state are exactly the same. They're exactly the same. The difference is just that they are arranged differently. So the particles before and after the change of state, they are the same. The only difference is the arrangement between the particles and the spaces between the particles as well. So now, how do we then take all of this information and represent it in a graph? How is it going to look like? So now, when looking at this graph, we have our 3 states of matter, whereby we have the solid, the liquid, and the gas. So now what happens as we are changing the temperature, or as we are adding or removing the energy from the substances? So when we are starting here, we're starting off with the solid. As we can see, the particles there, they are arranged and they're closely packed together, and there are small spaces between the particles. So when we increase the energy, when we add energy into the substance, they're going to start moving around more vigorously up until they get to a point where now the phase change starts to happen. So the solid is going to start to melt. It is going to melt for a certain temperature, and then when that happens, we are calling that the phase change. So they're changing their phase from a solid into a liquid. So now from this point going upwards here, from this point going to this temperature here, that solid has changed into a liquid. Now remember that we do not stop adding the heat. We do not stop adding the energy. We do not stop increasing the temperature. So as we continue increasing the temperature, increasing or adding the heat, there's going to be a phase change now from a liquid into a gas. Now, where is that going to be happening? It is going to be happening at this point here. So at that point, that's where now the liquid, it is going to be vaporizing. As we have said, the opposite is also true. When we remove the energy, the particles are going to go back to a solid phase, from a gas, liquid, to a solid. Now, those processes, as the substance is changing the phases from gas, liquid, to solid, what do we call them? So now, when we are going backwards, removing the heat now, when we're going backwards. So now we're going to start from a gas, and then now at this point there's going to be a phase change when we have removed a certain amount of energy, and then that point, that phase change is going to be, or the process between those 2 points is going to be condensation. Up to a point now whereby now that gas has changed into a liquid. That's now where the phase change occurs. We're going backwards now by removing the energy. So those liquid particles, as we keep on removing the energy, they're going to start now getting to this point where they start now going to another phase change. Now when they are freezing to a solid. So when we are removing energy, the substances are moving from gas, liquid to solid. And when we are adding energy, the substances are moving from solid, liquid to gas. And in between the phase change, there are processes. Moving from solid to liquid, the process is called melting. Then from liquid to gas, the process is called vaporizing. Now going backwards now, to start from a gas into a liquid, we call that process a condensation process. And then the last one, moving from a liquid into a solid, that process is called a freezing process. Now, what's important to remember, learners, is that this is the graph that shows the freezing and the melting of water. So all of these processes are of a water molecule. We need to remember that different liquids will boil and freeze at different temperatures. So if you're to look at a different substance, the graph is going to look differently. What we have here, it is a graph for the changing of water from phase to phase. Now, what's important to remember, learners, is that when matter changes state, that whole process is called it's a physical change, because nothing else changes. The composition of the particles remains the same. The only difference is the arrangement. They are moving from being tightly packed to loosely packed, and for them to being random. But then what they have done is they have changed physically. How you see them, that's how they've changed. But in the composition of the particles, they still remain intact and remain the same. Now we have an example that we have here, that our solid particle, it is moving from a solid to a liquid to a gas. But then notice that the particles still remain the same. The size of the particles will remain the same because the composition is exactly the same. And when we need to also note that when we are adding energy, we are moving from solid, liquid to gas. When we are removing energy, we are going from gas to liquid, and then lastly to solid. Now that's all I have for you today. I hope you enjoyed as much as I did. Until next time, bye.